Welcome back, guys, to part 2 of this trike strip and repair. If you missed part 1, link at the bottom, click on that, otherwise this isn't going to make much sense. Bits from America here, so we're going to start stripping. Hopefully we won't encounter too much issues, but now that I've said that, you know it's going to be, a pain in the backside. Anyway, guys, stick around. There we go, it's off. A god-awful job. Now that I've got it off, I can actually feel there's a lip on the end where the bearing's spun on the shaft. I'm just going to see how much wear we've got on there. So, the centre of the shaft is 48.6 and the larger edge 49.6. So we've lost about 1 millimetre of material on there. Now these hex bolts look like they're a bit damaged, but I might just be able to hammer a socket in there and just get this off. Okay, so these aren't budging. I even used my inductor here. The inductor doesn't work great on aluminium, but I'm trying to warm the steel up. It might be Loctited or just corroded in there. So much aluminium here, just drawing the heat away, so I'm not getting enough heat down there to try and free off the potential Loctite. I'd be surprised if it wasn't Loctited, because as this is spinning, you don't want that to come out. So I'm going to just persist with the heat for now and see if I can at least budge one of those. I just can't get enough heat into it. If you have a look where that bolt sits in there, if you come down, we've got a spacer plate and then the bolt goes into that aluminium base. I'm pretty sure it's Loctited in there, and I just cannot get enough heat to go from there down to there to loosen that off. So bit of a catch-22 at the moment. The only other thing I could probably try and do is get my blowtorch and just heat that up from down here, just to see if I can free that off. But other than that, there's nothing else I can do, unless I drill those out. But drilling them out, we still have that problem of freeing it off in there. Okay, can I get these bolts out? Just had the customer here explaining the dilemma. Looking back at where we were here, I've got a feeling those bolts might even bolt into here. Because if they went into the second aluminium plate there, what's holding that to that? So unless that's part of this as a machine parts, which is difficult to tell, these bolts might be really long, but I've had this super hot and it's still not coming out. Okay, so I need to draw these out now because I've got no other choice. I was thinking about doing it with a cordless drill, but I'm going to use my pillar drill. But trying to drill it on the pillar drill, that's just got no support at all. I've got some timber. We're doing some timber work above me. It's just the right height. It's just slightly higher than the base here, so I'm going to cut 4 squares out of that. I've got my nail gun there, we'll fire it together and make a base, and then that'll be sturdy inside the square box. Then I can use the pillar drill to drill through those properly. Okay, bolts are drilled. There's quite a bit of corrosion underneath here. I'll show that to you when I get it off. See if I can get this off first. If you can see that, there was corrosion underneath the heads of those screws, or the bolts. Well, there's the head of the bolts. I want to get the spacer plate off, but it's on there pretty tight. Really haven't got much space to put much underneath there. I don't really want to mar it, but it has to come off. See if I can get a pointy screwdriver just to get it off its seat, and then I'll see if I can pry it off. Okay, so these definitely aren't moving. I can see it looks like a red Loctite on there, which is usually bearing lock. I'm just going to try and reheat these with the inductor on the side, see if I can draw some heat back down into here and see if any of these move. There we go, it's out. You saw that we had the steel sticking out, how it actually drew the heat into the steel, got it cherry red, but it's trying to get the heat down into the aluminium, and aluminium is a really good heat sink, so it just dissipates the heat. But yeah, we got it out. I'm sure that was red bearing lock in there, that's why we couldn't undo it. So you would have always had to have drilled this out. Well, that was painful. It's taken me about 2.5 hours to get these bolts out. I wasn't sure how far this went back because this is the bit that's damaged, but it's half of the diff casing. Therefore, we're going to need this component if it's available separately. If not, this looks like it's going to be an expensive part. We have an engineering shop at the end of our estate, and they make aerospace stuff there, so they're equipped enough to machine us either another one of these, or the chap that works next door is a TIG welder. We don't TIG weld here. If he can build up the meat on this, we can get them to machine it down to the bearing size, and hopefully we'll be able to save that part. But I'll liaise with the customer and he can make a decision there. He's been speaking to the manufacturer of this rear axle in America. They're not very helpful, but he's going to try again and see how far we can get with it. It's been a while since I did part one. Customer ordered the parts from America. It took about a month to come in. To speed the process up, the customer bought the non-painted version, the non-powder coated version of this part to begin it quicker. Although we got the part, I know it was a month, but although we got it quicker, it's now escalated the work because now we've got to paint this. Customer asked if we could get it powder coated. Unfortunately, no, we can't. It's got a pre-installed seal front and back. Powder coating, which means it's got to go into an oven. There's a good chance we'll damage those seals. So I've tried to farm this job out to a couple of body shops. Nobody's interested in doing it. It's got a masked top and bottom, edge primed, painted. It takes about the same time as doing a car, and there's more money in a car than there is in this. So nobody wants to do it. So the job's fallen onto my head. So another Saturday in here. So got to prep this now. I'm going to get it edge primed. I've got edge primer in an aerosol, which is great, but with aluminium you must edge prime it, otherwise the paint will come off. Now the rest of the diff which this bolts onto, believe it or not, black does come in shades, so if I paint this it may be a shade out to the rest of it. So once it's been edge primed and dried, I'm going to have to bolt this up as one unit, prep the other side, and then paint the whole thing in black so that we've got the whole thing looking the same colour. Once it's mated, the black paint will fill this joining edge as well, so it will look like one continuous paint job. So let's get this masked up, let's get it at least edge primed, and then we can bolt it together, and then we can get it painted in one go. So I've got pretty much everything I need to make a start. It's panel wipe, Scotch-Brite, some tissues and some tape, and a blade, plus our edge primer. So there we go, we had 3 coats on there, it's fully cured. Now I need to get the rest of the differential, swap this over to the main unit, and then we'll prep the rest of it, and then we'll paint the whole lot in one go. And I've got a horrible feeling that to get these Allen key bolts out of here, and we've got 2, 4, 6, 10 of them. If they're Loctite as well, there's absolutely no way I'm going to get any heat into this to get those out. And they may need to be drilled out as well. still have my box. There's one. And that's 10. Can't believe it, they all came out. Very, very gunky. I don't know what they used. Okay, this diff looks like it's pressed into that inner lip. You can see the inner lip in there. So now I've got to try and get this greasy part out. You know, there's all that grease in there, it's all spat out and it's just metal on metal. Right, see if I can smack that out. So in the centre here is the planet gears, and there's a pin going through the planet gear. So the drive shaft comes in here on the other side, and the planet gear is in the pin for the planet gear is in the centre. So I'm going to drop that into that pin. See if we can knock the diff out. Bigger hammer. Yeah, that made a difference. There we go. There's the piece we're changing. And there's the actual diff. Well, the grease in here still looks good, so I'm going to just swoop that out, stick it back in there. Should really wash my hands because I don't want to get the primer all greasy, and then I'll probably wear some gloves. I'll use the gloves to grease this back up, and then I'll use my clean hands to put it together. By the looks of it, it's been siliconed, so I'm going to have to clean all that off and re-silicone it. Silicone here, on the underside and up top. So I'm going to clean this silicone first. I have to say, I was a bit surprised when I took this diff out and the oil came out. I've never ever seen a greased differential before. Yeah, this is just grey silicone. Plan is to put the differential onto this new part first. Then we'll grease the back and then we'll drop it into there after we've siliconed it. All the faces have been cleaned and degreased. So what we need to do now is apply some silicone, mount everything together, bolt it up. Right, it's Sunday today, back to work. Yesterday when I was siliconing this up, I've got some carburetor cleaner here. I was spraying it to clean the silicone and took all the paint off. This isn't powder coated. Powder coating, no chemical will get that off, only acid. You know, people get their alloy wheels done, the wheels dumped in a bath of acid to get that off. Well, this certainly is an acid, but yeah, it started to take the paint off. So in a roundabout way, it's a good thing. But after seeing that yesterday, I just had to go home. I'm going to get the rest of the paint off. It's not even 2-pack paint. It's actually coming off with my nails, just the paint itself, because I mean this bottom bit I didn't touch. It's not even 2-pack, because even 2-pack paint won't come off with that. So if I spray this now with 2-pack, I'm going to lose another day here. So I'm going to edge prime it again, and I'm just going to spray it with aerosol, because the paint down here is coming off so easily, and I haven't even touched the bottom part. Do you know, when I took this out, I was quite surprised at how easily the paint was chipping off it. Because normally powder coating and 2-pack paint, it's so tough that most things won't take it off. Get another one. If I just spray a little bit on here, straight off. That's definitely not 2-pack or powder coated. So I'll clean it all off, I'll remask it front to back, and we'll just paint it. If I just aerosol it in black, which is pretty much what's on this, I can start putting this back together today. There we go, like new. I mean, I took the paint off. On the end here, with a permanent marker, someone's written OK, but I couldn't get that off. So the permanent marker was stronger than the paint. Okay, going to mask this up now, and then we'll re-etch prime it, and then we'll just paint it. Okay, diff has been painted, all good. This is the left-hand side, so the near side to the curb. This face was all damaged when the bearing collapsed. This belt drive wheel scored up all in there, so I've had to paint that as well. I'm going to head over to my lathe, see if I can make this fit. If it fits, I'm just going to try and machine this scored edge down. See if I can neaten this up as well. There's a little face damage here as well. I'm hoping it's going to fit. I'm sure I've had bigger discs than this, you know, brake discs on there before, so I'll go over and have a look. If it does fit, I'll just do it and come back, but it won't know until we try. This wouldn't fit in my lathe, far too big. I took a walk down to the engineers at the end to see if they would be open today. They're normally 7 days a week, 24 hours, because they do a lot of aircraft engineering components, and the machines run continuously, and they have someone there to monitor it, but it's closed. But to be fair, they haven't got a lathe down there anyway, not that I can remember. All their stuff's big old CNC machines. Because they're working all the time, no one's going to switch one off to put this in there and pretty much help me. So I've wheeled the edges the best I can, I've cleaned it up the best I can. But to be fair, nobody machines stuff this big in a lathe. Most lathes are doing, you know, bars, solid bars or whatever they're going to do. But yeah, it won't fit, so it's going to have to go on as it is. Now when I stripped this bit by bit. You know, drive shaft, hub and all that came out individually. Now I'm going to put it all back together on the bench and put it in as one unit. I want to try and get this flange in first, and then I can put the diff on top of the flange. But to do that, the flange comes with a drive shaft, so the drive shaft is going to be sticking out here. So if I want to lift it and do any work, it's going to be awkward. This is quite stable, but I did have it up just now to clean it all the best I can before it goes back together. So I've just put this long extension bar in there so it wouldn't fall over. So I'm probably going to start with it sideways. We'll get the drive shaft in first, bolt that up, diff, and probably I'll try and remember how everything goes back. It's going to be the starter ring. It's not a starter, but it uses a starter motor to run backwards because of reverse gear. So that will have to go on before this goes on. I have got some fresh bolts, and I have got torque settings from the manufacturer. Remember, we had to draw these bolts out. They've got to go back in with red Loctite. Red Loctite is normally bearing lock. That's why it was so stiff to get out. Okay, we don't need these right now. We'll put this on this side. Let's get the drive shaft in. Okay, so we've got both drive shafts here. We've had 2 wheel bearings turn up. So you can see one of the wheel bearings here, one in here. This is the one that collapsed and failed. So we've got a new hub. It already came with a wheel bearing. They've also supplied a wheel bearing, so we don't need that. So that's for that. That's for that. We've got tapered bolts to go with the belt sprocket. Couple of bolts, 2 bolts here for something. Not sure what that is just yet. And that's for that. Okay. It's all cable tied together. There's a circlip in here, so there's a circlip in here. So we need to get the circlip out so we get the bearing off the end. Okay. Circlip's in there. So I need to get some big circlip pliers. Okay, need a vise. Okay, so I've got my mobile vise set up here. So I'm gonna, can't get the circlip out because it's bigger than the hole. So, and I can't grab it from anywhere else. So I have to see if I can knock the hub off. Luckily I'm replacing this one, but other than that, Wow, I had to go use my big vice in the end, and I had to get a bigger hammer. Finally got this out. There's actually two bearings in this. Looking at this one, looks like might be two bearings already in that one. Let's cut the cable tie. Yeah, so there's a bearing in for this bush and there's a bearing on the back. Same with that one, two bearings. Oh, I see, okay, I get it. Right, got two bearings already in this one, and these two bearings go into this one. But knowing how hard it was to get this off, knowing that I was replacing it, I mean, we've had to butcher that right up. I'll probably have to use my press to get that one out, so I have to be creative, I think. Okay, next door, press. Okay, done. So this is all back together. Now the hard bit is getting it back into that drive shaft. You may have noticed me hand pressing it near the end. It's an aluminium casing. When you've got your finger on the trigger, you have no idea what kind of load is being produced on the back of this. The last thing you want to do is crack this hub. Be another month's wait from America. Yeah, so the last bit I was just seating it by hand. I was using the wood so we don't mark the aluminium, because if we put it on that face, as you can see, it's not very clean, so you would have marked it. So, but when I pressed the centerpiece into the upper bearing there, I wanted it on something solid so that it wouldn't push this bearing back out. Okay, challenge 2, get it on the drive shaft. Right, so I've got the drive shaft clamped in the vise, pretty tight. I used this in the press when I was, one time we were crushing oil filters to take up less space in the bins. But it's hollow, which is great for the drive shaft, and it sits on the inner bearing face. So I should be able to hammer that in. Problem is the other side, the drive shaft's longer, it comes to about here. So that's going to be our next challenge. But in a minute, let's fix this one. Okay, done. Hardest part of this job was that circlip. Very small gap in there. I even swapped circuit pliers. To be fair, this one would have been better than this one. But I managed to get it in there. It's done. I had to go to the grinder and just grind some of the head off it. Okay, next one. Okay, this shaft has still got that collar on it from before, well, with the other hub. So I'm going to need to use my tool again to just get rid of this sleeve, because that sleeve's already built into this bearing. Here. That went straight on. That's not good. Yeah, there's quite a bit of play in there. Well, now I know why this bearing's packed up, because it's got the word China written on it. I mean, for the amount of work we've got to do, you know, you'd want to stick some decent bearings in this. Yeah, same. PRC, People's Republic of China. I'm not happy with that loose fit at all. I can feel the play in there. You can even hear it. Okay. Okay, I need to make the shaft bigger for it to stay in that bearing. So I've got a punch and ball peen hammer. So what I'm going to do now is I'm going to punch little dimples in there, and that will actually make the metal bigger. Yeah, it's getting tight already. So I'm doing that all the way around. Right guys, bearings all done, ready for assembly. This video is dragging on for a bit now, so we're going to call it a day for part 2, and then for part 3 we're going to come back, reassemble this as one unit, well close to one unit as possible. Obviously I can't put the calipers on because it's part of the vehicle. I've got to try and remember to put the belt on before it goes in. The whole idea of doing this was to do the belt as well. Because we've got to do all this to put a belt in, so if I forget to put it in, we've got to put it in after. So stick around for part 3. As always, hit the like, subscribe, and bell notification so you're notified when part 3 turns up. Take care guys.